Namaskar, welcome to PK's classes. Today we will study adjustment of tonicity by freezing point depression method. So before that, let us discuss what is osmosis. So you can see here, this side the solvent, say water, is there, and this side a solution is there, that means some solute molecules are there, and they are separated by a semi-permeable membrane. Semi-permeable means permeable to water, and impermeable to the solute. So the solute cannot enter into or through this membrane. So only water can move. So as per the law of equilibrium, both sides will try to have same concentration. And how they will have the same concentration? That is only possible if water will move from the lower concentration to the higher concentration. So the direction of solvent, because the solute cannot pass through, so only solvent can pass through, so all solvent will move from low concentration to high concentration. Suppose now we have two solutions, they are separated by, say, the semi-permeable membrane, and suppose this side we have high concentration and this side you have, say, low concentration. So to make both sides same, the solvent will move from the low concentration to high concentration. Solvent will move. So after some time, what will happen? This side will increase in the water volume, and this side there will be decrease in the water volume because of flow of solvent from low concentration to high concentration. So that process is called osmosis. So movement of solvent from low concentration to high concentration. And from that we have a term called osmotic pressure. So you can see here it is the low concentration and here it is the high concentration, and they are separated by a semi-permeable membrane here, and there will be flow of solvent from low concentration to high concentration, and because of that there is increase in volume of water this side, the side where the concentration is high. And from this we have this osmotic pressure, the pressure created by water moving across a semi-permeable membrane due to osmosis. So the pressure created by the solvent or water to move across the semi-permeable membrane is the osmotic pressure. And when two solutions have same osmotic pressure, we call them as iso-osmotic. So blood is also having one osmotic pressure, and any solution which has osmotic pressure equal to blood is called as isotonic. So we call isotonic solution a solution with osmotic pressure equal to blood. So the same solution is also having osmotic pressure equal to tear, also the lacrimal secretion. So osmotic pressure of blood or osmotic pressure of tear, if any solution is having the osmotic pressure same as that of the blood or tear, then we call it as isotonic solution. And the tonicity can be adjusted, because otherwise it will be either hypertonic or hypotonic, and what will happen, there will be movement of the solvent either from the cells or into the cells, into the blood cells. Suppose we want to add a solution to the blood, that means if the osmotic pressure is not same as that of the blood, then the cells present in the blood may either swell or shrink. So the cells will either may burst or they may shrink or die. So because of that, we need adjustment of tonicity. And freezing point depression method, sodium chloride equivalence method, molecular concentration method, and the graphical methods using freezing point and vapor pressure are also used. So today we are discussing about the freezing point depression method, and the most common used method. So freezing point, what is the freezing point? The temperature at which a liquid solidifies or freezes is called the freezing point. And we know freezing point of water is 0 degrees Celsius. And freezing point of blood is minus 0.52 degrees Celsius. So from this, the concept of the freezing point of tear is also minus 0.52 degrees Celsius. That means the contents present in the blood make the freezing point of water depressed by 0.52 degrees Celsius. So this is the depression, that's why this depression. So we can say that any solution that can depress the freezing point of pure water by 0.52 degrees Celsius will have the same osmotic pressure as that of the blood or tear, and thus will be isotonic. So we can calculate how we can calculate. So any substance the solution we want to add, the percentage weight by volume required, we can calculate by the freezing point depression of that 0.52, that is freezing point depression of caused by blood. So freezing point of blood, that difference, that is 0.52 divided by X, and X is the freezing point depression of 1% weight by volume solution of the substance to be added. Suppose another substance we want to add to the given solution. In that case, we will use the formula 0.52 minus A by B, where A is the freezing point depression of the given 1% of the given solution, or freezing point depression, actually freezing point depression by 1% of the given solution, depression by 1% of the given solution A, and B is the freezing point depression by 1% solution of the adjusting substance. So let us do some problems. What concentration of morphine hydrochloride would be isotonic if freezing point depression produced by 1% solution of morphine hydrochloride is 0.06 degrees Celsius. So as you know, percentage weight by volume is equal to 0.52 by 0.086. Here 0.52 by X, this formula we have used. So 0.52 by 0.086, so it will be around 6.05% weight by volume. So this concentration of morphine hydrochloride is required. Let us do one more question. We know that 0.9% weight by volume sodium chloride is isotonic. So let us calculate that. What concentration of sodium chloride would be isoosmotic to blood plasma or isotonic. So the freezing point depression produced by 1% weight by volume solution of sodium chloride is 0.57 degrees Celsius, 576 degrees Celsius. So if we use the formula, the percentage weight by volume sodium chloride required is equal to 0.52 by this freezing point depression by 1% weight by volume sodium chloride solution, that is 0.576. So the answer is 0.9% weight by volume. So this sodium chloride solution, 0.9% weight by volume sodium chloride solution is isotonic. So in this way you can calculate. So let us discuss another question. How much sodium chloride is required to make 1% solution of morphine hydrochloride isotonic? So we want to now add the sodium chloride to the given solution of morphine hydrochloride. So here we will use the formula. So percentage weight by volume sodium chloride required is equal to 0.52 minus A by B. So here what is A? The freezing point depression caused by morphine hydrochloride, already have done. 0.52 minus 0.086, this is the A, and B is the freezing point depression caused by 1% weight by volume sodium chloride, that is 0.576. This is B. So from this we can calculate, and it will be around 0.75% weight by volume. So if it is a 100 ml solution, so in 100 ml solution we will add sodium chloride 0.75 gram. Suppose it is 200 ml solution, then 0.75 into 2 equal to 1.5 gram, like this. What is, next let us discuss another question. What is the amount of sodium chloride required to be added to make 2% solution of quinine hydrochloride isotonic? So the same formula, 0.52 minus A by B, but here instead of 1% it is given 2%. So we can change the formula, 0.52 minus AC by B, where C is the concentration of given solution. So what data we need here? A, the freezing point depression caused by quinine hydrochloride, and that is freezing point depression by quinine hydrochloride, that is 0.077 degrees Celsius. And B is, we want to add sodium chloride, so the freezing point depression caused by 1% weight by volume sodium chloride is 0.576 degrees Celsius. And here C is 2% of that, so now we use the formula, 0.52 minus 0.077 into 2 by 0.576 is equal to almost 0.635% weight by volume. So for 100 ml 0.635 gram. Accordingly, the volume, as per the volume, we can calculate the amount. Suppose a solution is having more than one ingredient. So far we have discussed for only one ingredient. So if it has more than one ingredient, suppose for this example, pectidine hydrochloride as well as sodium metabisulfite, two ingredients are there, and here is percentage is not given, 50 ml solution is there. So in 50 ml 0.75 gram, 50 ml 0.75 gram. So we have to calculate it for 100 ml. So 1 ml 0.75 by 50 gram, 100 ml, so 0.75 by 50 into 100, so it will be 1.5%. So the pectidine hydrochloride percentage 1.5%. Similarly, sodium metabisulfite, so 0.01 gram, 0.01 gram in 50 ml. So for 100 ml, accordingly you can calculate, and it will be 0.02. So for 100 ml if it will be 0.02, so it will be 0.02% weight by volume. So first, since it is the percentage is not given in this question, so for 50 ml it is given, so we have changed it to 100 ml, and accordingly the percentage is 1.5% is pethidine hydrochloride and 0.02% sodium metabisulfite. Then the data: freezing point depression by 1% solution of pethidine hydrochloride is given, freezing point depression by 1% solution of 0.386 of sodium metabisulfite, which is 0.386 degrees Celsius, is also given. Now calculate the amount of sodium chloride required to make the solution isotonic. So in this case, the same formula, this formula will be used, but since two solutions are there, we will sum them. So the formula will be like this: 0.52 minus summation of AC by by here we can write the B first. So in the formula it will be 0.52 minus summation of AC by B. So summation of AC means here for pethidine hydrochloride ones, for sodium metabisulfite ones, we will do that. So that will be 0.52 minus A 1.5%. Sorry, this is C, and the A is 0.125 degrees Celsius. This is the freezing point depression. So 0.125 into 1.5 plus, for this is 0.386 degrees Celsius. So 0.386 into C is 0.02. So this one divided by B, sodium chloride freezing point depression, so that is 0.576. So this will be around 0.52 minus, if you calculate this one, this will be 0.195 by 0.576. So it will be around 0.564. So percent weight by volume of sodium chloride. So for 100 ml 0.564. For 50 ml, since in the question it is 50 ml, so 50 ml sodium chloride. So for 100 ml we need 0.564 gram sodium chloride, and for accordingly for 1 ml and for 50 ml. So it will be 0.564 by 100 into 50. So this is the answer. So accordingly we can solve the problems using freezing point depression method to adjust the tonicity to make the solutions isotonic. Thank you.